Whether an electrical contractor should charge a customer for furnishing the generator and automatic transfer switch depends on the specific terms outlined in the contract between them. In typical industry practices, if the contractor is responsible for both providing and installing the generator and automatic transfer switch, it's common for the bid or estimate to include the cost of these materials. The customer typically isn't charged separately for the equipment itself. However, if the customer is responsible for providing the generator and automatic transfer switch, the contractor might charge a labor-only fee specifically for installing the equipment. In this scenario, the customer purchases the generator and automatic transfer switch independently and provides them to the contractor for installation. Several factors come into play when determining the appropriate charging structure. Firstly, contract terms are paramount. The contract should explicitly state who bears the responsibility of providing the generator and automatic transfer switch. Secondly, consider who is sourcing the equipment. If the contractor is responsible for sourcing and purchasing the equipment, they will likely incorporate the cost into their overall bid. Conversely, if the customer is sourcing and purchasing the equipment independently, the contractor may only charge for the labor involved in the installation process. Thirdly, project size and complexity play a significant role. Larger or more complex projects might necessitate specialized equipment or additional labor, which can subsequently influence the pricing structure. Fourthly, market conditions can also impact pricing. Fluctuations in the cost of materials and labor based on prevailing market conditions can affect the final pricing. It's highly recommended that the electrical contractor and the customer establish a clear and mutual understanding regarding who is responsible for providing the generator and automatic transfer switch before commencing any work. This proactive approach can help prevent misunderstandings or disputes related to payment down the line. Let's delve deeper into the aspects of generators and automatic transfer switches to better understand the context of these charges. A generator serves as a backup power source, kicking in when the main power supply is interrupted. It converts mechanical energy into electrical energy, providing a continuous power supply during outages. Generators come in various sizes and capacities, catering to different power needs. An automatic transfer switch, or ATS, is a crucial component that automatically switches the power source from the main utility to the generator during a power outage. It ensures a seamless transition, minimizing disruption to essential systems and appliances. The ATS constantly monitors the incoming voltage from the utility power source. When the voltage drops below a predetermined threshold, indicating a power failure, the ATS initiates the generator and, once the generator is up and running, transfers the electrical load to the generator. When utility power is restored, the ATS automatically switches the load back to the utility and shuts down the generator after a cool-down period. When an electrical contractor is involved in furnishing the generator and automatic transfer switch, they take on responsibilities beyond just installation. They may assist in selecting the appropriate generator size and type based on the customer's power requirements. This involves calculating the total power load of the circuits that need to be backed up during an outage. The contractor may also handle the procurement of the generator and automatic transfer switch, ensuring that the equipment meets all relevant safety standards and local codes. Furthermore, the contractor is responsible for coordinating the delivery and placement of the equipment, which may require specialized equipment and permits. In addition to the cost of the generator and automatic transfer switch themselves, the contractor's bid may include costs associated with permits, inspections, and other regulatory requirements. The installation process involves connecting the generator to the electrical system, which typically requires running new wiring, installing conduit, and making connections to the main electrical panel. The contractor must ensure that all wiring is properly sized and installed in accordance with the National Electrical Code, or NEC, and local electrical codes. The automatic transfer switch also needs to be integrated into the electrical system. This involves connecting the ATS to the utility power source, the generator, and the main electrical panel. The contractor must configure the ATS to operate correctly, ensuring that it switches seamlessly between the utility power and the generator power. The installation process may also involve installing a concrete pad for the generator to sit on, as well as providing weather protection for the generator and automatic transfer switch. The contractor may also need to coordinate with other trades, such as plumbers and gas fitters, to connect the generator to a fuel source. After the installation is complete, the contractor will test the system to ensure that it is operating correctly. This includes verifying that the generator starts automatically when the utility power is lost, that the ATS switches the load to the generator, and that the generator provides sufficient power to the backed-up circuits. The contractor will also provide the customer with instructions on how to operate and maintain the generator and automatic transfer switch. Regular maintenance is essential to ensure the reliability of the generator system. This includes changing the oil, replacing the air filter, and inspecting the spark plugs. The automatic transfer switch should also be inspected regularly to ensure that it is operating correctly. Now let's consider some specific scenarios. In a residential setting, a homeowner may want to install a generator to back up essential circuits, such as the refrigerator, lights, and heating system. In this case, the electrical contractor would typically provide a packaged generator system, including the generator, automatic transfer switch, and all necessary wiring and components. The contractor would include the cost of the entire system in their bid. In a commercial setting, a business owner may need to install a larger generator to back up critical systems such as computers, servers, and life safety equipment. In this case, the electrical contractor may work with a generator supplier to select the appropriate generator and automatic transfer switch for the application. The contractor may then provide a separate quote for the installation labor. In an industrial setting, a manufacturing plant may need to install a redundant generator system to ensure that production can continue even during a power outage. In this case, the electrical contractor would work closely with the plant engineers to design and install a complex generator system with multiple generators and automatic transfer switches. The cost of the generator system would be a significant part of the overall project budget. Regardless of the setting, it is important for the electrical contractor to provide a detailed proposal that clearly outlines the scope of work, the materials to be used, and the total cost of the project. The proposal should also specify who is responsible for providing the generator and automatic transfer switch, and whether the cost of the equipment is included in the bid. It is also important for the customer to carefully review the proposal and ask any questions they may have before signing the contract. Once the contract is signed, both the contractor and the customer are legally bound to its terms. If there are any changes to the scope of work or the materials to be used, these changes should be documented in writing and agreed to by both parties. By following these guidelines, electrical contractors and customers can avoid misunderstandings and disputes regarding payment for generator and automatic transfer switch installations. Understanding the nuances of electrical work, particularly concerning generators and automatic transfer switches, demands a firm grasp of electrical codes and safety regulations. The National Electrical Code, or NEC, serves as the cornerstone for safe electrical installations in the United States. It's a comprehensive set of standards that governs everything from wiring methods to equipment installation. Article 700.12 of the NEC specifically addresses emergency systems, including generators. It outlines the requirements for generator installation, wiring, and maintenance. It also emphasizes the importance of regular testing to ensure the generator's reliability during emergencies. Another crucial aspect is grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. The NEC provides detailed guidelines on grounding and bonding methods, including the use of grounding electrodes, equipment grounding conductors, and bonding jumpers. In the context of generator installations, it's crucial to properly ground the generator frame and connect it to the building's grounding system. This helps to minimize the risk of electrical shock and ensures that the generator operates safely. Overcurrent protection is another critical safety consideration. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fire. The NEC specifies the appropriate size and type of overcurrent protection devices for different types of circuits and equipment. In generator installations, it's important to provide overcurrent protection for the generator output circuits and the automatic transfer switch. This helps to prevent damage to the generator and the electrical system in the event of an overload or short circuit. Wiring methods are also regulated by the NEC. The NEC specifies the types of wiring methods that are permitted for different applications. For example, rigid metal conduit, or RMC, is often used for underground wiring and in areas where the wiring is subject to physical damage. Electrical metallic tubing, or IMT, is commonly used for indoor wiring. Non-metallic sheathed cable, or NM cable, is permitted for use in residential wiring. In generator installations, it's important to use wiring methods that are suitable for the environment in which the generator is installed. For example, if the generator is installed outdoors, the wiring must be weatherproof. The NEC also addresses the installation of automatic transfer switches. The NEC specifies the requirements for the location, wiring, and operation of automatic transfer switches. It also requires that automatic transfer switches be tested regularly to ensure that they operate correctly. The NEC also addresses the requirements for labeling electrical equipment. The NEC requires that electrical equipment be labeled with information such as the voltage, current, and power rating. This information is essential for ensuring that the equipment is used safely and correctly. In generator installations, it's important to label the generator, automatic transfer switch, and other related equipment with the appropriate information. In addition to the NEC, local electrical codes may also apply. Local electrical codes are often based on the NEC, but they may have additional requirements that are specific to the local area. It's important to check with the local electrical inspector to determine which codes apply to a particular installation. Failure to comply with electrical codes can result in fines, penalties, and even legal action. It can also create a safety hazard that could put people at risk. Therefore, it's essential to hire a qualified electrical contractor who is familiar with the NEC and local electrical codes. A qualified electrical contractor will ensure that the generator and automatic transfer switch are installed safely and correctly, in accordance with all applicable codes and regulations. They will also provide you with the necessary documentation and permits to ensure that your installation is compliant. In Maryland, where the location information was provided, electrical work is regulated by the Maryland Department of Labor, Licensing and Regulation. Electricians are required to be licensed, and electrical installations must comply with the Maryland Building Code, which incorporates the NEC. The Maryland Building Code also includes specific requirements for generator installations, such as the need for a permit and inspection. The code also specifies the minimum clearance requirements for generators and the requirements for ventilation. In addition to the code requirements, there are also a number of best practices that should be followed when installing a generator and automatic transfer switch. Firstly, it's important to choose a generator that is properly sized for the application. The generator should be able to provide enough power to meet the needs of the circuits that are being backed up. Secondly, it's important to install the generator in a well-ventilated area. Generators produce exhaust fumes which can be harmful to your health. Thirdly, it's important to protect the generator from the weather. Generators should be installed in a weatherproof enclosure or under a roof. Fourthly, it's important to maintain the generator properly. Regular maintenance, such as changing the oil and filters, will help to ensure that the generator operates reliably. Fifthly, it's important to test the generator regularly. Testing the generator will help to identify any problems before they become serious. Installing a generator and automatic transfer switch is a complex task that should be performed by a qualified electrical contractor. A qualified electrical contractor will ensure that the installation is safe, code compliant, and reliable. By following the NEC, local electrical codes, and best practices, you can ensure that your generator and automatic transfer switch provide you with a safe and reliable source of backup power.